Hello, welcome to the Spirit of Apollo. I'm your host, Mark Lesmeister. As you can see, our rocket is coming right along here. Today we're going to work on bag 11, and after we finish that, I'm going to talk a little bit about some of these motors along the side of the rocket, and also talk about what it means to be weightless. So here's bag 11, and I will let you know how it goes. So in bag 11, we end up making the S4B stage of the rocket. This is the third stage. This is the stage that actually gets the astronauts into orbit. And then the engine is turned off a little bit. And after a couple of orbits of the Earth, when they're ready to go for the moon, they'll get the call from Mission Control, and they will execute their trans-lunar injection burn, which will set them on a path to the moon. Now that means they're going to have to restart this engine. And that's going to be a problem. In order to understand what that problem is and how some really smart people solved it, I'm going to have to tell you a little bit about weightlessness. If you think that weightlessness results from the decreasing pull of gravity, you would be in good company. Jules Verne, in his book From the Earth to the Moon, had his travelers encounter the weaker and weaker gravity of the Earth the farther away from the Earth they traveled, along with the stronger and stronger gravity of the approaching moon. At some point in the trip, one would encounter a region where the pull of gravity is the same amount from both bodies. That's the point where you would turn your spaceship around. Jules Verne thought the travelers would feel weight until they approached that neutral region, where they would become weightless just for a short while, because the pulls of gravity equalize. But then, as they get closer to the moon, they would have weight again. It's true there would be a region where the gravity fields of the Earth and moon neutralize each other. But that's not what causes weightlessness. Consider the astronauts in orbit on the International Space Station. Clearly, they're weightless, but they're not far enough away from the Earth for gravity to have diminished all that much. In fact, according to the formula for gravity discovered by this guy, the force of gravity at the location of the ISS is about 90% of what it would be on the surface of the Earth. So, if the force of gravity isn't that much less, why are the astronauts weightless? Well, let's remember what Newton said about objects in orbit. If you need a refresher, check out episode 4 of this series. He said that, just like a cannonball shot from the top of a high mountain, things in orbit are falling. It's just that for an object in orbit, it's moving fast enough so that it falls towards the Earth at the exact same rate as the Earth falls away from it. Okay, so an object that's in orbit is in free fall. How does that make it weightless? Imagine you're in a box that's falling towards the ground. The box and everything inside of it, including you, would be falling at the exact same rate. So you would float around, and you wouldn't know if you were just not near any source of gravity or if you were in free fall, unless you had perhaps a window that you could look out and see the clouds go by as you fall past them. So, being in free fall in a gravity field feels just like being far away from any source of gravity at all. In fact, according to Albert Einstein's equivalence principle, they are the same thing. The point is, once our travelers are launched towards the moon, they would be in free fall the whole time, and so they would be weightless the whole time. So what does all this have to do with the pods on the side of the S4B? Well, remember, the S4B engine is fired to get the rocket into orbit around the Earth, and then it's turned off. After a couple of orbits, the engine is restarted to get the rocket going towards the moon. Now, liquid rocket propellant tanks usually are not completely full. The space at the top, called ullage, is filled with gases that pressurize the tank. Starting the rocket engine when the rocket is on the ground is not a problem. The liquid propellant rests against the bottom of the tank, which is where the engine intake valves are. But when the rocket is in free fall, i.e. weightless, the propellant floats around inside the tank, mixed with the ullage gases. Small rocket motors called ullage motors accelerate the rocket forward, causing the rocket propellant to settle in the bottom. This is much like the feeling we get when we're being pushed back into our seats when we're in a car that starts accelerating forward. The S2, S4B, and service module stages all had rockets that acted as ullage motors. On the S4B, the auxiliary propulsion system pods had 4 rocket motors, 3 along the side of the pod to control the rocket's orientation in space, and a smaller one pointing down to act as an ullage motor. On the service module, the reaction control rockets could serve as an ullage motor. Mr. Norm Chaffee was a NASA chemical engineer who helped design the service module reaction control rockets. He also worked on the S-4B's auxiliary propulsion system. The APS pods were how the S-4B rocket's orbit was adjusted after its last burn. So if you ever come to Houston and visit Johnson Space Center, you can go out to Rocket Park and impress your friends with how smart you are because you know what those little pods are for. I think the takeaway from all of this is that we can all be smart people. We can't all be Einstein or Newton, but there are certain things we can do that smart people do to solve problems. First, realize that most problems are solved incrementally. There's not just one big solution for the whole thing. Second, realize that there's often more than one way to look at a situation. Consider Newton's description of gravity, which differs radically from Einstein's description of gravity. Third, realize that even an incorrect solution can contribute something. Think about Jules Verne's description of weightlessness. So next time I think we're going to work on the last bag of the model. Until then, Godspeed.